SwayamPrabha. Digital India. Educated India.
So far we have been drawing CM, CG versus alpha. Okay, so this is a case, and we also know this is for a particular CG location. Now I can easily translate this into equivalent graph CM, CG versus CL. Because after all, if I know what is alpha here, I know what is the corresponding CL, because CL is nothing but CL naught plus CL alpha into alpha. I know CL alpha, I know CL naught. So once I know alpha, I know what is the CL. So I can scale it up. I can still the variation of CM and CL will remain like this. Now if the variation is CM and CL like this, let us see what is the equilibrium point. Please understand, from CM versus alpha graph, I am now shifting towards CM versus CL graph. And I understand for each alpha there is a corresponding CL, so I will be replacing alpha by CL. So let's say that is the graph it has come. Now our question is, let us check about the trim point, about the equilibrium point, whether this aircraft is statically stable or not. We know it has to be stable, slope is negative, but we know only that CM versus alpha slope is negative. But because alpha and CL can be related like this, so we know by number the slope has to be negative. But let us add some physics to it. Let us see an airplane was moving like this, okay? A cruise, our equilibrium is cruise. Let's say because of some disturbance, CL has increased. What is the meaning of that? Because of some disturbance, CL has increased. It was going at a particular CL, let's say 0.2. That was corresponding to, say 3 degrees. Because of some upward gust, the 3 degree has become 5 degrees. So I will say, now the CL has changed. The perturbation is on the CL. Let's say CL has changed. This point. From here, it comes to this point. What will happen? The airplane immediately generate negative pitching moment. Negative means nose down. So this aircraft will have initial tendency to come back to the equilibrium. Negative means try to reduce angle of attack, so CL will reduce. Similarly, if there is a reduction in CL, then this aircraft will generate positive pitching moment, which will try to, again, has initial tendency to come back to the equilibrium. So we see that, indeed, about the equilibrium, as the CL is changing, it has initial tendency to come back to the equilibrium. So for static stability, dCm by dCl should be less than 0. It is nothing great, because we know that dCm by d alpha should be less than 0. We have spent a lot of time on that, and alpha CL are related by this, so its slope has to be less than 0. But we will be now using this definition for static stability instead of dCm by d alpha. You can use both, but designers can use sometimes dCm by dCl less than 0, sometimes dCm by d alpha less than 0, depending upon what is his requirement. Okay. Now let us also understand CM, CG and CL. Please take a note, now I am using CM, CG versus CL graph, which is equivalent with little bit of numerical scale up or scale down, CM versus alpha, right? And for static stability, dCm by dCl should be less than 0, or which is equivalent to dCm by d alpha less than 0. You can see this, dCm by dCl, I can write as dCm by d alpha into 1 by dCl by d alpha in a linear domain. dCl by d alpha is CL alpha, which is always positive. So whatever sign dCm by d alpha is having, dCm by dCl also will have same sign. But this is a positive number. right? So that's why I was telling it is scaling, that's all. Let us say airplane is flying here and this is the trim point. That is, what do you know trim point? At this point, thrust equal to drag, lift equal to weight. The airplane is flying like this. Now there is a requirement that aircraft should fly at a higher CL. Still maintain lift equal to weight. That means he wants to fly at a lower speed. So to balance the lift equal to satisfy the lift equal to weight condition, if he is flying at a lower speed, he has to fly at a higher CL or higher angle of attack. So this is this case here. The moment you try to come to this point, what happens? This man will generate a negative pitching moment because that is statically stable. You cannot help it. It will always have initial tendency to oppose. But you want to fly here. Graphically, you want something like this. Your graph CM versus CL should like this. Now, this point is a trim point, but what is happening? The moment I try to go there, it generates a negative moment. You have to counter the negative moment so that it stays here. Graphically, I have to shift this graph from here to here. So what is required? Required, you have to give additional delta Cm naught. If I can generate this additional delta Cm naught, then this will become trim point, or indirectly what I am telling, whatever negative pitching moment this aircraft is giving, I need to produce a positive pitching moment to counter it, and that is this. Okay? How do I do that? How do I generate this additional moment? Let's see. This is your airplane. This is your tail. Let's see, fuselage. Elevator. Let's say you are flying at CL equal to CL star. I call this initial as CL star. You want to go to CL double star. The moment you want to go to CL double star, you find there is a negative moment generated by the airplane about CG. Which way? Negative, that is nose down. So I have to counter this. So what I have to do? I have to give a positive moment. So I will take the elevator up. As the elevator goes up, force acts here downward, and this gives a moment which counters this negative moment, balances the negative moment. And if I try to interpret delta Cm naught, what is happening now? You see, the moment I am putting the elevator up like this, and at alpha equal to 0, this is giving moment about Cg, and this is what is delta Cm naught. This is here. Is it clear? If I want to go from here to here, the aircraft will generate negative moment. That means I have to generate a positive moment equivalent to this, so that this is countered. I give a elevator deflection up, that counters it, and that is how this graph gets shifted from here to here. Please note that by giving elevator deflection, the stability has not changed, the slope remains same. By giving the positive, giving the elevator up deflection, please understand elevator up is negative deflection, so we will be saying elevator up, and this is elevator down. Okay? So we will be giving, let me repeat again, if you are flying at CL star, if you want to fly at CL double star, which is more than CL star, this aircraft, our aircraft will generate a negative pitching moment. But I want to fly here means at this point the net moment should be 0, net pitching moment should be 0. So I will be using elevator in up configuration to generate a positive moment so that this moment is countered, and I can fly at higher CL. If I try to explain through this graph, if I want to fly at this CL, which is CL double star, I have to add additional delta Cm naught. And since elevator deflection doesn't change the stability, slope remains same, to add this delta Cm naught, I have to put the elevator up, and definition of Cm naught is Cm at alpha equal to 0, this is the wing, at alpha equal to 0, there is a force downward which gives a positive moment, that is in our case delta Cm naught. If you want to fly at another CL star or triple star, again you have to see how much additional moment it will generate with respect to this equilibrium. So this negative moment I have to again compensate, so I have to further put the elevator up. But you cannot go on putting the elevator up or down, because beyond a certain deflection the flow will separate, elevator will become ineffective. So there is a restriction. In general, 25 degree plus minus is good enough. 25 degree plus minus means delta E plus minus 25 degree means plus is down and negative is up. This is negative and this is plus, positive. So plus minus 25 degree is a good assumption that flow will not separate. I hope if you have understood this, what I am doing, I am having trim points 1, 2, 3. I was flying at CL here. I want to fly at another CL. When I was flying here, I checked that I am statically stable because the slope is negative. So when I want to go from this CL to this CL, because this is statically stable at this equilibrium, it will generate opposing moment. To fly at here, with Cm0 I have to generate positive moment. So I give elevator up. Same thing here. So from one equilibrium to another equilibrium to another equilibrium, this process is called control of airplane. One of the aspects of control of airplane in the pitch plane, or you call longitudinal control. This flying at different equilibriums, at different CL here, 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 this problem we call control problem, and stability part here. So it gives you a connection between stability and control. Okay? Please understand, if I am trying to fly from one equilibrium to another equilibrium, because they are statically stable, they will generate negative opposing moment. To discourage that change, and you have to give moment from outside. For a longitudinal control, it is elevator. To see that whatever opposing moment is coming is taken care. Equivalently saying, you increase the Cm naught by delta Cm naught. Both are same statement. Okay? So you are seeing one aspect of control, which is longitudinal, using elevator. Now again I come back to a configuration which is flying wing, right? Let us say this is a flying wing. By now we know it has to be a reflex aerofoil, and this is the CG and this is the AC. So if I draw, this is a reflex aerofoil, we write reflex aerofoil. Of course, what we mean by that is it's a wing, flying wing, having a reflex aerofoil. Take the cross section, it's having a reflex aerofoil. If I plot CMCG versus alpha for this configuration, you know that alpha equal to 0, there will be Cm naught, at alpha equal to 0, there will be a force downward which will give you positive moment. So this graph something come like this. And statically stable, AC is behind CG. No problem. We are expert in this now. You know by now that if I am flying a flying wing and I want that flying wing should trim at a positive alpha so that enough lift is there for a given velocity to balance weight, then not only the aircraft should be statically stable, or that is the aerodynamic center of the wing should be behind CG, but also it should be able to by itself generate Cm at alpha equal to 0, which I call Cm naught. Because when I am talking about flying wing doesn't mean it doesn't have an elevator. So there is a clarity you must have. Generally, whenever you design an airplane or a flying wing for that matter, you design for a particular mission. So of course it will have a takeoff, it will have climb, it will have a cruise, it will have a maneuvers, but you are designing always for one of the most important aspect. It could be cruise. So if it is for a cruise, then you will like that at cruise altitude, which is pre-decided, at cruise altitude, at a cruise speed, V cruise, which is again pre-decided in the design stage itself, you would like that the airplane wing, tail should be laid out in such a way that automatically it should be able to generate this Cm naught at alpha equal to 0 without deflecting the elevator. Please understand, if I am deflecting the elevator of a flying wing, and suppose by deflecting the elevator, you can generate Cm naught. You know very well. If it is alpha equal to 0, this will generate force downwards, say about Cg. It will also give a Cm naught. So if your design is inferior, then you have one option. At that altitude, you deflect the elevator by a requisite amount so that it generates this much of Cm naught. But do you think that's a good design? Definitely not. Because most of the time you'll be flying like this, and because of this deflection there will be drag, and unnecessarily you are giving penalty. So what you would like? We should look for a design so that this flying wing will fly, and by itself it should generate Cm naught positive even when delta I is not deflected. And by now you know how it can be done. How it can be done? You know, it cannot be done for a symmetry configuration, but it could be done for a reflex aerofoil. Okay? I can design and select a reflex aerofoil and manufacture flying wing using reflex aerofoil configuration, and this you know, this will generate Cm naught when at alpha equal to 0. The message is very clear that if I want to make an airplane, design an airplane which is statically stable, and it should be able to trim without any elevator deflection at the altitude or the cruise condition you are flying most of the time, then Cm naught should be generated by wing and tail and other components, not by the elevator. Now suppose you are flying at this condition here. Now this is delta E is 0. Now for some time you want to fly at a different alpha with different CL. Then what does it mean? It means it will generate negative moment. So you have to now use elevator in an up condition, so that it gives a positive moment about CG, and this gets nullified, and your Cm versus CL graph becomes this. So now again it is a trim point, and effectively you could see by deflecting the elevator I have increased Cm naught value. So this is a control problem. Okay? So this is called the control aspect of the airplane, and there is a limit to which you can deflect the elevator, typically for normal configuration plus minus 25 degrees. There are mechanisms to increase that also. But physics should be clear, the mechanics should be clear. If I want to fly here, I know if I want to fly here, as far as the basic graph is concerned, this will generate a positive moment. So I have to counter it. So I should give elevator now down, because if I am from this point, if I want to fly here, it will generate positive moment. So I have to ensure that the elevator is deflected down so that it gives nose down moment about center of gravity somewhere here. Because as I put it down, there will be lift increment in the upward direction, which will give about CG a nose down moment. So that will counter this positive moment, and I can say that this line gets shifted here, and this becomes my trim point. So this delta 0 to delta negative, delta down is positive, delta negative means delta up. These are the convention used, and if you see a chart, you will find frequently this sort of a graph or variation is displayed for a pilot to know if you want to fly at this speed, what are the elevator required, and he gets a feel for the airplane. Thank you.